Preview video, solving a system of equations using elimination. Recall that a system of equations is more than one equation with the same variable. In this particular graph, we have two equations. We have x plus 2y equals 5 and 2x plus y equals 4. The solution to the system is the one solution, in this case, where the two lines intersect, because the solution 1, 2 is a solution to both equations, while we have an infinite number of solutions to our first equation and an infinite number of solutions to our second equation. The only solution that works for both equations is where they overlap, 1, 2. But we can't always graph the lines because we don't always have a graph, and sometimes our solution won't be integers, so it will be difficult to read on a graph. So let's look at a different method for solving a system of equations. Another way to solve a system of equations is called elimination. We find an additive inverse, such as x and negative x, or 2 and negative 2, shown on the right, so that when we add them together, we get 0. The reason we want this is that we want to be able to add our two equations together, and when we do this, we want one of our variables to cancel out. So I look at my like terms, and I see that I have 3x and negative 3x, and when I add those together, they'll cancel out. So I know that I already have an additive inverse, and therefore I can add my two equations together. 3x minus 3x is 0x. 4y plus 2y is 6y, and 1 plus 5 is 6. So I'm left with 6y equals 6. Because I have one variable left and one equation, I can figure out what that variable is by using inverse operations. And I find that y itself equals 1. Now that I know what y is, I can substitute this into either of my two equations above to find x. I've rewritten my first equation, but instead of y, I've put 1. So I have 3x plus 4 equals 1. 3x equals negative 3 because I subtract 4 from both sides, and then I divide both sides by 3 to get that x equals negative 1. This means that my solution is negative 1, 1. Remember that we always want our solution to be an ordered pair, and if I had graphed the two lines, this would be the one spot that they'd intersect. My final step is to check to make sure that my solution works in both equations, not just one, because that's what it means to be a solution to the system. So instead of 3x plus 4y equals 1, and negative 3x plus 2y equals 5, I substitute in my x and y, making sure that I put them in the correct places, and I see if these come out true. Negative 3 plus 4 equals 1, so I know that this is a solution to my first equation. And 3 plus 2 equals 5, so I know that this is also a solution to my second equation. We'll be working on this in class, so don't worry if you still have questions. This was just a quick introduction. Don't forget that the steps are that you look for an additive inverse, or create one, which we'll work on later. Then you add the two equations together, and because we have an additive inverse, one of our variables goes away. You can solve for the remaining variable and use that value substituted back into either of your original equations to find the other part of your ordered pair.